In this video, we are going to introduce two of the most important concepts in Kubernetes after the idea of a pod. These two concepts are those of replica sets and of deployments. In order to understand these, let's dial back to what a pod is in the first place. We've said this a bunch of times. A pod is the atomic unit of deployment in Kubernetes. A pod is kind of a sandbox inside which one or more containers run. These containers represent the app which we wish to host in our Kubernetes cluster. Pods by themselves are vulnerable. They do not offer either self-healing or auto-scaling. For instance, if all of the containers in a pod crash, there is no mechanism inbuilt in Kubernetes to bring them back up or to create a new pod on a different node. Likewise, if the amount of demand for our app goes up, there is no mechanism at the pod level to increase the amount of compute capacity devoted to our application. These are two fundamental properties which folks have come to expect in the world of cloud computing: self-healing and auto-scaling. And these properties are made available through a higher level construct called a replica set. A replica set can be thought of as an object. It is a high level object in Kubernetes which encapsulates within it a pod definition, that's a pod template, as well as the number of replicas of that pod which must be in operation. So again, a replica set brings us self-healing and auto-scaling in the context of Kubernetes. A deployment is an even higher level object. Just like a replica set encapsulates within it a pod, a deployment encapsulates within it a replica set. If auto-scaling and auto-healing are obtained using the replica set, then the deployment is going to give us versioning, fast rollback, and advanced deployment features such as green-blue deployments, canary releases, and so on. We will formally introduce each of these types of objects in videos up ahead. But again, at a high level, remember that a pod wraps within it containers, a replica set wraps within it a pod template and a number of replicas of that pod which have to be maintained, and a deployment wraps within it a replica set along with versioning information and functionality for fast rollbacks and advanced deployment options. So far, so good. Hopefully, we are now clear on the high level view of what pods, replica sets, and deployments are. Let's now understand why these are all managed by different types of controllers. For a moment, let's cast our mind's eye back to the control plane of the Kubernetes cluster. We have seen how user commands come in through the form of RESTful API calls and are intercepted or interpreted by the API server. Metadata associated with those commands is stored in an etcd key value data store, and pod creation and scheduling operations are performed by the scheduler. The fourth remaining part of the control plane was the controller manager set. There are different controllers for each of these types of high level objects: replica sets, deployments, as well as other types of controllers which we have yet to introduce, such as stateful sets, daemon sets, cron jobs, etc. All of these controllers have the same basic purpose. These controllers are going to take in the desired state of the system, which was specified by the user in the JSON or YAML manifest file. They are then going to run loops, reconciliation loops, which are going to constantly evaluate the actual state of the system, that is the actual state of the Kubernetes cluster, and reconcile the actual and the desired state. So for instance, the controller associated with a replica set might notice that one or more pods have gone down, maybe they've crashed. This means that there is a deviation between the desired number of replicas, which was specified in the replica set specification, and the actual number of replicas of a particular pod. Then this replica set controller will take whatever action is necessary in order to spin up additional replicas of that pod until the actual and the desired states of the system are back in perfect sync. Controllers are an important part of the control plane. They are effectively endless loops which reconcile the actual and desired states of the system. And there are more controllers than those we just referred to. We already mentioned replica sets as entities which allow us to scale and perform auto healing on pods. We also mentioned deployments as a further high level construct which are associated with versioning and rollbacks. In addition, there are other types of controller objects we should be aware of. Stateful sets, these are similar in some respects to deployments. A difference between stateful sets and deployments is that the individual replica sets or pods that are running as a part of a stateful set are identified using unique identifiers, so they are not completely fungible. Likewise, there are run to completion jobs. These are effectively pods which are spun up, which do their thing and then terminate and fade away into the background. Run to completion jobs are a common construct. If we would like to schedule their construction at a particular time, there is a specific type of run to completion job called a cron job. The name hopefully gives you a good sense of what it does. Now that we have a decent high level understanding of what the different controllers are and of what functionality we get using replicas, deployments, and run to completion jobs, let's quickly cycle through and understand or double click on each one of these controllers in turn.